Hey, in this video, I will be showing you how to build and run the GigaDORAM benchmarks that went into making the data in our paper, which will be published in USENIX Security 2023. And we're doing this because we had quite a fun time running other people's DORAM benchmark code, and we wanted to show that that our instructions should work, and also like if you're getting stuck, maybe watching this video will help you get unstuck running our code. So I'm just going to go through and follow the README that I wrote, and if anything comes up that wasn't in here, I will try to address it in the video and maybe also change the README later. So first thing is to run our single machine tests. You just need a pretty basic Linux computer. We do recommend at least, you need at least 4 for this to be like sane, but 8 is probably better for a number of CPU cores and some RAM. Like honestly, it doesn't use that much RAM. So, you'll need to install the EMP toolkit library, which like we considered to be a light enough dependency that we just like hope you install it. And I'll show how to do that in this video. So I'm going to fire up an AWS instance from scratch, just to show that there was nothing, like we're starting from a blank computer here. Give me a second, I'm gonna log into AWS. All right, so here's the AWS EC2 dashboard, and I am going to launch a new instance using Ubuntu 22.04, although I think the other distributions should mostly work as long, or not Mac OS, but the other Linux distributions should work. And I'm going to get a c6i.2x large, which is not too pricey, but does cost something. Like, I don't know, a smaller one would probably work also. I'll create a new key pair. Use some cool elliptic curve type stuff for smaller keys. Okay. So creating a key pair will download the private key, which is stored in a .pem file, to your computer, and that's the only way you'll ever be able to access the private key, so don't lose it. Other than that, I think the default network settings are enough. We'll be able to SSH in. I'll make a new security group and use that security group later in the video. And 8 gigabytes is fine. So let's call it GigaDORAM build demo. And I will launch the instance. Okay, cool. So now I'm going to SSH into the instance. So to do that, you can just yeah, so then there's this other thing, which is like you need to change the permissions on your key file to be only readable by you and not allowed to do anything else by any other group or everyone. So chmod 400 for those permissions. I mean, this is like, I think, pretty well-known stuff, but it's also easy to forget, as you can see. So, all right, let's try again. Okay, and we're in. Cool. So I'm going to start following the. Actually, first I'm going to install EMP Toolkit. So EMP Toolkit has instructions here. Basic instructions are to download their script. It's not hard to read if you don't trust it out of the box, which is totally reasonable. But I'm just gonna do this on 3. So it's running apt to install its own dependencies, which are like mostly super basic stuff that I think no one would object to having installed on their own computer. Blah, blah, blah. So, okay, I guess like if you're new to recent Ubuntu, like apt has started showing those scary like we're gonna restart these services messages when you install stuff, and like I think you can basically always just hit enter on that and skip it. Um, yeah, it would be nice if this soft screen recording software would like show the like control keys that I'm hitting. But I'll try to say out loud if I'm hitting any interesting keys. So okay, anyway, we installed EMP tool. And I think that was, I guess it put its stuff in its own EMP tool directory, but that's basically all we'll have to think about that, hopefully. So the next step is cloning our repo. So quick. And let's go inside, and there's a compile script. Okay, cool. So it compiled. We're past this part of the README. So to reproduce figures 6A and 6B from the paper, these were run on a single machine using TC to set like some network settings to simulate a network with certain bandwidth and delay on the loopback interface. And those experiments can be automatically run with single server experiments.py. If you just first run it with the help flag, you can see all the things that you can configure here in the supported experiments. And if I want to actually run something, you'll note that because we did all our benchmarks on these like huge c5n.metal instances, the default number of threads is 20. Maybe we should change this, but I think like just in general, if you're running on a computer with less CPUs, like you should not use like more than, or this number should be less than 1/3 the number of your CPU cores. Otherwise, there's just like no point. So I'm gonna do 2 threads since this computer has 8, or this virtual machine has 8 CPUs. And other than that, yeah, you can also change the number of queries to run, but like the data that we generated was done using 5,000 queries. So I'm just going to keep that. And if it works, you should see some output that, if you've read the paper, will maybe make sense what's going on, but it will print every time it needs to rebuild a level in the hierarchy. And then it will like. So once we succeed at, I'm just going to stop it early. Once we succeed at finishing a test, the output will be written under this directory, single server results /DORAM timing report I for party I in 1, 2, 3. So let's look at. say party 1, and it follows the following format. So first, we will tell you what time you ran this. Hopefully, this will let you remember or like figure out what you were trying to do then, and then like it'll show the latency and bandwidth settings that were passed to the or like that the local network was set to, and then a bunch of DORAM specific info. And maybe the most interesting numbers are down here. So just say we'll tell you the total times that take 15 seconds, 1.5 times 10 to the 7 microseconds. There were 200 megabytes sent about and 328 queries per second, which is pretty close to the data in the paper, despite using a significantly smaller computer. So, or probably actually didn't need to use those huge machines. But anyway, yeah, this file is pretty human readable, and the all of the different options like should hopefully make sense in the context of the paper. I think one thing we didn't talk that much about in the paper was this like build bottom level at startup yes or no thing. Uh, I don't know. That's outside the scope of this video, but essentially like some of our experiments we decided to skip building the bottom level at startup and then build it like it will be rebuilt if it needs to be, but like at a slightly like in a slightly more inefficient way than we could if we had like built a bottom level at startup. But anyway, um, yeah, okay. So it looks like single server tests are working. You can also run very like if you want to dig deeper because maybe you're writing a competing paper or something. You can run a test with very specific like you can configure all of the parameters that should affect DORAM performance. So like network uh, capabilities and all of the like I guess they're all listed here. The maybe I don't know like the most interesting ones are like how big the DORAM is. That's specified using log address space. We only support powers of 2, and yeah, these are like you basically have to read the paper to know what these do, but like um, you can specify arbitrary combinations of parameters. And just to prove that this works, I'll run the example. Oops. Okay, it's running. This is actually 100,000 tests or 100,000 queries, so I'm gonna kill it. Also, like these scripts should clean up if you interrupt them and unset the TC thing. But if you notice anything weird going on, like I think VS Code is a big user of the loopback interface, and so like it might run slowly if you like set a queuing discipline and don't unset it or something. So if you want to go back to where you were before, we have the command in here. You can run you can undo the qdisk thing with tcqdisk del, but that doesn't do anything when there's nothing currently set. So yeah, okay. Those were the single machine tests. Now for the multi-machine tests, the AWS setup is a lot more involved, but I will show at least one way to get it to work here to prove that it's possible. But unfortunately, these are harder to run, at least with the setup that we have. Like you could probably try to simulate this with like 3 Dockers or something, or just run single machine tests. But like for better or worse, we wanted to try running our thing on 3 actually different machines and see what kind of performance was possible on 3 different machines. And turns out on AWS, pretty low latency and high bandwidth are possible from 3 distinct machines. even when they're definitely not the same physical on the same physical machine, because like we got uh, giant instances that, at least according to an AWS engineer, could not physically fit on the same uh, physical underlying machine. So, uh, okay, right. So we have the way that these scripts that run our tests work. They will look up AWS instances by their names. So you have to create AWS instances with particular names, and you have to do a bunch of other AWS stuff that is easy to screw up. So follow these directions carefully. Um, we want to use the same SSH key to access all of them. Set the security group settings to allow TCP traffic between three instances. And for a lot of the tests, we used a cluster placement group to minimize latency and simulate a yeah. Anyway, where was I going with this? We will also need to you need to choose to launch your instances in a cluster placement group at the time that you launch them. So I will go through all of those things now. So let's pull up AWS. I'm going to first create a new placement group. So you can see I've done this before, but just to show how to do it, it's pretty simple. Give it a name and a placement strategy, and that's it. Okay. Placement group exists. So let's now launch 3 instances into that cluster placement group. So now we got to pay a bit more attention to so I'm going to have to rename them later, or actually it's not GigaDORAM, DORAM, benchmark underscore, and we'll have to remember to rename these afterwards. Launching 3 instances using Ubuntu, e5n.metal, because why not? And so I'm going to use the same key pair that I just downloaded. But I think as long as you use one key pair for all 3 instances, it should work. If you do, instances need different keys to log in. I mean, you can fix that situation, but it's honestly probably easier just to restart and make new instances. And we will just put it in the same security group that got created when I made the other instance. This is like a blank security group, so we're going to have to change some things about it. And 8 gigabytes of storage is enough. And then under advanced details, this is where you pick the placement group to launch it into. So I'm going to put it in the cluster placement group that I just made. Blah, blah, blah. Wait, where is it? Blah, blah. Placement group. I don't know, I missed it the first time. I guess we could have created it on this screen too. Okay. And I think that's all I needed to do on this screen. As you can see, there's definitely more stuff to remember. So let's go back to our instances, and I'm going to rename them DORAM benchmark 1, 2, and 3. And that should be it. I guess the scripts that we have could be pretty trivially modified to take IP addresses instead of, well, they kind of, like, I don't know. I think they should be run on AWS. And if you have 3 like machines, say like in your like labs network or something, and you want to run on those, like it's not that hard to modify the scripts to not be AWS based. Like you're probably more deleting stuff than adding stuff, but uh, yeah, our what we provide is designed for AWS. So uh, right, there's the security group as well. So right now, this security group is only allowing SSH. So I'm going to add a new inbound rule that allows custom TCP on port. Not sure if port 0 is all ports. I'll just allow it from everywhere because I don't know. This thing isn't going to be up for that long. I'm going to go delete it after this video. So, but at your own risk, I guess. And ports, I don't know. I think 0 might have just been fine, but whatever. Any ports. And let's save. Okay. So if I did everything I needed to do, should be able to run the multi-server tests, but there's a solid chance that I missed something. So let's go try. SSH key, right. So I'm going to need to upload the SSH key to the place where I've built GigaDORAM. So I'm going to exit and SCP looked a little funny. The hem file to the build server. Okay, and now let's go back. So anyway, we need to set up AWS CLI. So install it. So after you install AWS CLI, you should run AWS configure and pass it your access keys and the region that you're in. So I'm going to go do this off screen. Okay, so I just ran AWS configure, and if you run AWS configure list, you should see something for your access key, secret key, and the region should be the same region that your benchmark servers are in. Now, hopefully, we should finally be able to run. So let's look at the help text. It takes an experiment and a PEM file as unnamed arguments. So remember, I SCP'd the PEM file up. And besides that, I don't think I'm going to mess with the number of queries and the number of threads. So if this works, it should start printing some GigaDORAM output. All right, there we go. All right, so we just finished running one of the tests. I'm going to cut us off here and show that the results are stored under multi-server results. And they follow the same format as the single server results. Okay, there's a bunch of stuff from failed attempts, and then the successful attempt shown here. And same format, but the network settings are not included because we didn't set them. So you'll have to test the network settings yourself. And it shows that we're getting around 800 queries per second with this particular size and setup. Thank you for watching. hopefully this video helps you move past any roadblocks to running our GigaDORAM and benchmarking its performance for yourself. And thank you for your interest in this corner of multi-party computation. See you at a conference someday, maybe. Okay, bye-bye.